An audio signal is a function of amplitude over time. In this case, amplitude is an acoustic force. It's sound pressure. This is the pressure that gets exerted on the diaphragm of a microphone or on our eardrums. This acoustic force is created by a vibrating object. As an example, a speaker cone, which can move forward and backward. When it moves forward, it pushes up against air molecules, creating a chain reaction. When it moves backwards, it pulls on these very same air molecules, causing them to vibrate back and forth many times per second. This characteristic of the signal is called its frequency. As listeners, we can perceive these vibrations when they happen within a range of about 20 times per second, all the way up to 20,000 times per second. There are many different ways that we can measure these vibrations, to store and record them, and also process them. One way to do this is to measure the amplitude of the signal at regular intervals in time. This is the process of digitization, or sampling of the signal. In another video, I'm going to talk about why sampling works the way that it does. In this video, let's just focus on the end result of the sampling or digitization process. We start out with a continuous or analog representation of the signal as it exists in physical space, and we end up with a digital signal, which has measurements at regular intervals in time. Let's take a closer look at this. Here's a simplified description of the sampling process. We start out with a continuous analog signal, electricity that comes from a microphone. In this case, we're visualizing a signal's amplitude against time. This signal is created when the diaphragm of a microphone moves back and forth. When it gets pushed forward, it's going to create a positive force. When it gets pulled backwards, it will create a negative force. And we can look at this change in pressure over time. We end up with these types of oscillations. Next, let's think about the process of taking discrete measurements of our signal to digitize it. This is called sampling. During the sampling process, we're going to take measurements at regular time intervals. The spacing between each sample is called the sampling period. The number of samples per second is called the sampling rate. After we're done with the sampling process, all that we're left over with are the individual measurements. Let's take a closer look at what does one individual measurement actually represent. In this case, it's nothing more than an amplitude value, or more specifically, a number. This number lines up with a specific point in time. And once we have all the individual measurements for our signal, we can place them in order in sequence and then organize them in an array. So in the case of this signal, we start out, our first element is the number 0. Our second element is number 0.81, and so on for the remainder of our signal. This is the sampling process, where we end up with, in the end, a sequence of numbers. Now that we've looked at this process of creating a digital signal, let's move on and talk about what are other things we can do with this signal once we've brought it into our computer.